Chem bonding.
Hmm. Molecular orbital theory that was.
Mott. So you're taking chem bonding right now?
Yes, it's almost completed.
Okay. So you finished mole concept, periodic properties,
Yes, they are completed.
atomic structure.
Completed.
Now chem bonding.
Yes.
What about this thing, the equilibrium?
Equilibrium is not started yet. After this will start.
Oh, okay.
You have completed chemical equilibrium.
No, sir, we are continuing chem bonding.
Chemical equilibrium is easy, but ionic equilibrium is bit tough, bit
Mm,
lengthy.
yes, I guess so. Because we need to know a lot.
Because actually, hmm,
So physical chemistry, how many topics are 11th and how many for 12th, sir?
actually the way topics, if I say 4 or 5 topics only in the class 12 and here also 4 or 5 topics.
So then so this year there'll be inorganic and physical. Next will be this will be organic and physical. Next year we'll deal with inorganic and
The most part of the inorganic you will see in the next year. But that too in the from the JEE main, the major portion is also actually removed. Means
uh,
the reaction part, na, actually they used to ask reaction part is actually removed. And also metallurgy part is also removed in JEE main, but it will be there in the advanced.
it's not there, sir. Metallurgy
Metallurgy is not there in JEE main.
for advanced it's there.
For advanced it's there.
Oh, okay.
Acha, could you solve this question?
Mm. 1 second, sir. I guess I should use it.
Okay.
Let me check.
Priya, what about you? Did you solve this one?
No, sir.
Then try solving it.
So it'll be root. No, 1 second, sir. I'll check. I'll do.
You have to see which part will be maximum, which part will be minimum.
The velocity at maximum will be root 5 GL.
Sir, what should be the answer?
5.
Can you solve it?
Sir, I'm getting V square is equal to 5.
Hmm. a small bob tied at one end of a thin string. Length 1 meter is carrying vertical circle. Situation is this. Maximum tension will be bottom one. Why, you know? Because here tension, this is mg. If we make the equation at the bottommost case, it will be T minus mg will be equal to mv square by r. If we say the velocity is v1 here, v1 square by r. Because here the tension, if same thing we make at the top, how the equations will be?
Here it's maximum at the bottom and minimum at the top, right?
Yes. How do you know?
Uh, I have solved this kind of problems, sir.
Yeah, so even we also
Acha, let
derive.
me, but you should know now why it is maximum and why it
We
is
derive the same way we did.
Sir, because while going up, the potential energy increases and the kinetic energy decreases. But while coming down, it's like more like a free falling body.
no, that's not the actual explanation. See, the answer is actually in the results. If you see this equation, compare these two equations now. Here, if you see that T1 will be what? T1 will be equal to mg plus mv1 square by r. Here T2 will be mv equal to mv square by r, mv3 square by r. So the maximum will be this only. So T1 will be maximum and T2 will be minimum. Just by looking at it, we can do it. Now they have given what? They have given
the maximum and the minimum tension ratio.
in the ratio is given, means T1 by T2 ratio they have given. So it will be mg plus mv1 square by r divided by mv2 square by r minus mg will be equal to your 5:1. The velocity of the bob at the highest position. Acha.
So that's what I told. It'll be root
Mhm.
5 GL by when we have to derive V, sir, from that.
You have to derive this.
You
How?
don't need to derive these, sir. You'll get
Why?
it. Sir, take LCM.
But
Oh
V1 and
no,
V2
we'll
are
get
different, no?
V1. Oh
Hmm. You have to have this condition. I should have derived this earlier.
Circle, like circle, what motion of circle, vertical circle.
If it is doing that, how do you derive? If you have known this, how do you derive? Tell me.
Yesterday
You,
only I got.
yesterday only.
Yesterday only in class we learned. Not able to recall. I remember the result, but I forgot. It was like really big, sorry. Like what board it took.
Actually, it's not that difficult. It's easy only.
Easy only, but I am not sure.
Idea, do you remember? You also know this formula, root 5 GR.
So it should be known, right, sir? Like
No,
it should be remembered, or we have to derive an exam.
no, in exam it's not needed to derive. You should know, but why it is, you should, that also you should know.
Yes, sir. That is also.
See, because why do we get this V1 as root 5 GR? Because if it is describing a vertical circle, means it is just reaching the point V2, just reaching the top point. So between A and B, okay, we do not know what the velocity is. So here, one equation that we can make is half mv1 square must be equal to mg into 2r plus half mv2 square. Okay, it's describing the vertical circle, correct? I have just made an equation between A and B, law of conservation of energy. Okay, now to complete this, see, if I say the velocity at this particular point becomes zero, that is not the correct thing, because to describe the complete circle, if we make the velocity zero here, it may just fall down like this. In that case, it won't describe the complete circle. Okay, correct? Now, what the condition I should put here, the tension may become zero. If I just, after completing this, if the tension at the maximum case at reaching the point B, if the tension becomes zero, what will be the condition at point B? T2 plus mg will be equal to mv2 square by r. So here T2 is becoming zero. So what will be there? V2 square will be equal to gr. Okay, so it will be equation will, this will become mv1 square by 2 plus 4 mg, so equal to 4 mgr divided by 2 plus m into mgr divided by 2. 2 gets cancelled, m also you cancel it. So v1 square will become equal to 5gr. So v1 will be equal to root 5gr. Now you understood why we are applying this formula. To describe the vertical circle, see, you have the two conditions. The point A, after it is after the ball is projected, this point here, it is projected from point A, it moves to this point B. If it has to complete the circle, you will think of two conditions. One condition is I will make the velocity zero. But if you make the velocity zero, there will be problem. Means the problem is it will stop here. It will just stop here. It will stop here. It will not, it will only have, so the central, this velocity is not there. So tension will be equal to mg. It will fall like this. It will not complete the circle. But if it has to complete the circle, if it has to describe the vertical circle, in that case, at the maximum case, the tension at the stop point should become zero. So that means what? The velocity. So tension should be, you remember, if you are feeling confusion here, if it is has to describe the vertical circle, complete circle, then its velocity is not zero, v2 is not zero, but tension at t2 will be equal to zero. Okay, that's why you get v1 is equal to root 5gr. Now if you put this value, you will get the answer. 5 by 1 is equal to mm, you get cancelled. G plus 5g by 2 square by r minus g. So 6g by 5 plus g is equal to v square by r. So 7g by 5 r. This is v2. What is this?
So did we get? We got the answer.
You see, we check the answer.
So,
Hmm.
so I have a small doubt, bro.
Tell me.
Like related to work financing. Sir, coefficient of restitution is same as coefficient of friction.
Correct. No. Coefficient of restitution is E. Coefficient of friction is mu.
So, in PYQs, they've given some questions, like there was a question with coefficient of restitution. Like, should we take it as mu or how, sir? So,
No. It's not. No, it's not necessary that you have to take coefficient of restitution as coefficient of friction.
okay, sir.
Both are different.
Okay, but it has been in one of the PYQ question has been given, sir. So,
Mm, just send me that one. I want to see.
okay.
What we are doing wrong? They're saying the answer is 25, 5 meter per second. They are getting. The ratio maximum to minimum is this one 5/1. Okay. mg plus v1 is 5 gr.
Sir, could you move up 1 minute?
Mhm.
Sir, if they're telling about string attached to 1 meter of length, wouldn't be it uniform circular motion?
No. Vertical circular motion can never be uniform. It's not a uniform circular motion. But I don't think so. There, here we have to apply this condition. This condition that I have derived now, I think we do not have to apply it here. That's why we are getting the wrong. Because they have done what? Describing a vertical circle. It is describing a vertical circle, the whole circle it is describing. See, to get the value of V2, you have to apply the law of conservation of energy between A and B. That's all. This equation you have to apply. You do not have to put that condition. Root 5gr condition you need not put here. Getting it? That's the limiting case, but they have not told us about the limiting case, See, we have to get the relation between V1 and V2. We will get the relation between V1 and V2 just by using the law of conservation of energy between A and B. How? Using this condition between A and B, I have applied the law of conservation of energy. M will be cancelled. So we'll get V1 square. We have to find V2, no? So we'll get V1 square is equal to 4gr plus V2 square. We'll put it here. So 5 into V2 square by r minus g will be equal to g plus V1 square is 4gr plus v2 square whole divided by r. Shama, understood?
Yes.
Here it is not needed because see, if there was no other way, you could have used that condition of root 5gr. But using the law of conservation of energy only, we are getting the answer. So why apply the limiting condition? So it will be 4 v2 square by r is equal to 10g. So r is what? They have given what? 1 meter, na? So v2 square will be equal to 10 into 10 divided by 4. Now you'll get the answer. 2 is equal to 10 by 2, so 5 meter per second. Now correct. This is the answer they have given.
Okay, sir.
You have to remember whenever these, why I gave this vertical circle question to you, whenever a vertical circle question will be given to you, just think in a circle you have to apply this tension, this centripetal force equation. One thing is clear. Other thing that you have to do is you have to apply the law of conservation of energy because conservative forces are only there. Let me see if I have one more question like this. I'll try to give you.
So the same type of question they've given spring in the middle. How do you solve?
Spring?
Spring in the middle.
Spring is in case
No, here instead of a line, there was a spring
there is spring.
of radius 2r.
In that case, it the spring will expand. There will be different expansions. Means the bottom place it will have different expansion x1. The top case it will have different expansion. Only the tensions in case of tensions you have to write kx1 and kx2 there. If the spring was there here also spring was there.
Okay.
So here this tension will become, if suppose the expansion in this has become x1, so the spring tension will become kx1. And here the expansion has become x2, then the tension will become equal to kx2. That's all. The problem will be solved in the same way.
Okay, sir. There's a
But
P by Q based on this.
but it's a good question. In this case, what you have to include, if you are applying the law of conservation of energy here in this a part, you have to add half k x1 square also. Here you have to add half k x2 square also. Okay, like that. And to get the relation between x1 and x2, you have to equate them because the spring is kept as it is. So the tension T1 should be equal to tension T2. If they will give some condition to you. Then kx1 will be made equal to x2. So somehow you have to find out the relation between x1 and x2 also. Okay.
Okay.
Sure. Try to solve this.
So will you also color equilibrium?
Equilibrium Newton's laws.
No, sir. Stable, unstable, potential energy.
That also I'll tell you.
Partial differentiation.
That's only a theoretical concept. On the basis of that, two questions are, but I'll tell you it's very small thing. There are three
Can you
cases.
give some, sir, can you give some questions?
I'm giving them, selecting one. What is a stable equilibrium? When you displace a body from that position, the body always tries to reach that point again. That is supposed to be your stable equilibrium. This is a very common example. After this, I'll tell you. Try to solve this one.
These are the hectic problems in this chapter.
Try this.
So can you solve?
You are not having idea. Let's see Haripriya also. Haripriya, do you have any idea?
But I don't have an idea about the contact with the surface.
Acha, wait, let me see.
It's when the body doesn't have normal reaction. So
A small block slides down the top of hemisphere. The height at which the block will lose contact with the surfaces. This will lose when it will lose contact, there will not be any normal reaction. That's your hint. Can you solve using that hint? Shama, Haripriya, Kanishka. See, again, you have, I'm telling now, in all the work power energy questions of this type or some complication with complicated questions, you have to apply mostly the two equations only. One is either if it is doing circular motion, you have to make the circular motion equation, the tension, centripetal acceleration, those one. That equation one. Second one is you have to make use of law of conservation of energy. See, suppose, I'll give you a hint. Suppose here at this point, it loses contact. Okay. This is mg. This component will be mg cos theta. This component will be your mg sin theta. Here should be normal reaction, but because it is losing contact, normal reaction will go. So if I make the equation at this particular point, well, this is A, because they have already given
Will
it.
be mg cos theta h.
Mg cos.
mg sin theta h.
No. Mg cos theta. Now I'm making circular motion equations. Circular motion equation, gamma. Mg cos theta will be equal to m v2 square by the radius. This is circular motion equation. It has the velocity v2. I did not consider n because why? Because n is 0 here. Because it is losing contact at this point. Understood? This is circular motion equation. I'll write. Now the other equation I'll make is, did this say something out? Slides down from the top is the height at which the body will lose contact. Acha. Slides down means it at this point it did not have any velocity. So from here to here, I'll make conservation of energy equation. Half mu square plus, if I take this as a reference, the difference between them is suppose h. If I take mgh will be equal to half mv2 square.
So they've given the reference as r minus h.
It's up to you. whatever you want to do. Acha, they have, if you want to take like that, you can do like that. They have given, so I'll do like them only. So plus mg into r minus h. H is r cos theta. So this is 0. So mg r minus r cos theta is equal to half m v2 square. It's easy now. Will get cancelled. v2 square will be equal to 2gr into 1 minus cos theta. To put this v2 there, what they have asked, I don't know.
How did you put R into R cos theta here?
Here r minus r cos theta. See this one. This is a triangle. Okay.
Okay.
This is radius. This whole is a radius. This is angle theta.
Okay. So this will be R cos
R
theta.
cos theta.
Oh, okay.
So like this. So mgr into r minus cos theta. But what they have asked h, na?
Yes, sir.
Achha. So I'll just put that v2 value here. I'll get again. I'll cancel. So it will become g cos theta is equal to rg cos theta is equal to 2gr minus 2gr cos theta. So gr I'll cancel. So 3 cos theta is equal to 2 means I'm getting cos theta is equal to 2 by 3. What is
Okay.
h? H is equal to r cos theta we had. So h will be equal to 2r by 3. That is our answer.
Okay.
Was it difficult?
It was a bit conceptual for Newton's laws of motion and
See, actually, that's why I actually tried to cover circular motion before in the motion in a plane. Because I knew that in the work power energy, you will be using the circular motion equation most frequently.
yeah. Okay.
Okay, na?
So one small doubt so units and dimensions can you cover, sir, like after some time?
So do you want? I'll cover it, no problem.
So because in JEE mains also they're asking questions, so
But if you have exam, we'll cover it before, but it's not
they
needed.
didn't cover for us, sir.
Acha, and then I'll cover. No.
It's important, right, sir? Like for mains because they'll ask error like how to the
See,
formula.
there is only one question that they will ask every time they ask, and I can say you.
So I saw the Singate, so they have given questions based on in the back page of NCRT we have that one 3 pages, sir. Where there'll be dimensional formula for all the units, like many units. Match the following type.
Do not try to memorize them all.
We
Just
could type them.
when this whole 11th portion will be covered, na, and your 12th portion will be covered. All those formulas that you have there, you already will know.
Oh,
So
okay.
it will become very easy to find out the dimensional formula. That's just you need to remember the method. What method you are using to find out the dimensional formula. And using those methods, we know now how to compare the units and all. Those things are there. And then again, using the dimensional formula, we do the error analysis. Those kinds of things only you should know.
Error analysis is deleted, sir, in NCRT. That you could.
But in JEE, the error-based questions are asked.
In mains.
In mains. Every year, one question is asked in mains for finding out the errors. Relative error.
Oh.
Do this one.
So what should be the answer?
The answer is 2 meter per second.
I got it.
Very good. Emma, what about you? Are you getting it? Try to do this question.
It will be option C.
No, options are not there. It's 2
No,
meter. It's numerical type. What answer you are getting?
so that's all I'm getting 5/2.
Why?
Not sure, sir.
Wait.
Can you like solve so I could like check with my steps?
Acha, I'll do it. Wait. See, actually, the situation is pendulum bob has a speed of 3 meter per second at the lowest position. Let me draw it. See, this is a situation. This is the pendulum bob. It is 3 meter per second at the lowest position. The pendulum is 50 centimeter long, means 0.5 meter. Speed of the bob when the length makes an angle of 60 degree with the vertical. Now they are asking the situation when this has made an angle of 60 degree with the vertical. In this situation, what is the speed of the bob?
Oh, okay, now I know.
Simple thing you have to do, just do the
Find
law.
the height by cos theta and then I drew the diagram.
This is actually 0.5 cos 60,
Mm.
this height, and this total height was 0.5. So this will be your 0.5 into 1 minus cos 60 height h.
Mm.
So here,
Now half mv square equals the mgh plus
no,
half.
no. Half mv square plus mgh is equal to half m into 3 square.
That's what I told. I told
Acha.
in the
Okay, that's correct. So you can cancel out. So it will become v square plus 2g into 0.5 into 1 minus cos 60 is 1 by 2. So it will be 9 equal to 9. So v square 2 will get cancelled. 5, 4. So v will be equal to 2 meter per second. This is one more, but this one you do as homework because similar kind of question we have actually done. I'll give you one interesting question here. Very nice. Try solving this. Are you able to get the idea how to solve it?
Or I'm getting my answer in decimal.
1.12 you should get.
Let me check.
I'm giving this as homework to you. Try
I'm
this.
putting 4 point.
What idea did you put? See, if this has the velocity v, this will have the velocity 2v. So the work will be done only by the friction on this. Mu into normal mu into mg cos 30. Here mg cos theta, na? No, no. Acha, mg also will be doing the work. But you have to take work done by mg and mg sin theta.
Yes, sir. Because the block is also moving down.
Yes. So if it is moving down by a distance x, so you will take
Yes.
mg sin theta minus mu
Minus
into
mu
mg cos
mg.
theta.
Sir, I made a mistake. I didn't consider the velocity of B using tension equation. Yes, sir. And then you have to add half mv square, right?
Half ma b square plus half mb into 2v whole square. This is the final kinetic energy of the system. Initial kinetic energy of the system is 0. Using this, you have to do. X is already
I
given.
didn't take, I took this as minus, so this will automatically go plus. Okay.
No, you have not. No, positive only you have to
I
take.
took my plus half mv square on this side.
Acha. Okay, then no problem. But answer you should get correct then.
I didn't take the velocity of block B.
Ah, that's why.
By tension equation, there's a constraint 2T.
By constant equation here, it will be 2t. 2t into this velocity of A will be equal to t into velocity of B. So 2VA will be equal to your VB.
Now we have to substitute the values.
That's all. That's why I have taken V and 2V. Just you have to substitute the values and then get the answer.
I didn't take 2v square. That's why I'd have gotten my answer wrong.
That's why. Be careful. That's why I gave this kind of question. The answer you should get is 2.12. 1.12, sorry. 1.12
1.12, sir.
meter per second. Yes. They have given the everything, given question, given this concept, and if you are able to solve, okay. In the next class, probably in the half of the class, we'll complete this chapter because some cases of the vertical circles are there. I'll explain all those cases, 3 cases in which it completes the circle, in which looping the loop, those conditions are there. And then 3 types of equilibrium, then we'll complete it. Then we'll start the new one. Collision. Then we'll move on to the collision part. Okay, let's end it then.